Okay, let's take a look at today's lesson. So what we're going to be looking at are just a little bit of a few different ways to work with parametrics. In today's lesson, we will be given some equations, and sometimes a graph, sometimes not, but we're going to be given equations, and we're going to be asked to do some, just some problem solving with it. Like, for example, this first example says the curve crosses the y-axis at the point A and crosses the x-axis at the point B. So they're just kind of highlighting the fact that this is point A, it's actually on the y-axis, and this is point B, which is actually on the x-axis. They're just kind of laying that out there for us. So part A says show that A has coordinate 0, 3. So that's kind of a classic AP calculus question type. When they'll say show that, and they'll give you the answer, and they are really expecting your answer is the work. You have to show the work on how to get to the answer. They already gave you the answer. They'll do that in certain circumstances when the equation is kind of difficult and that you would be using the equation in a different manner. So here we're just practicing show that A has coordinate 0, 3. So they already tell us the answer. We need to kind of get to it algebraically. So let's think about what it means to be here on the y-axis. If a point is on the y-axis, we know that the x value is 0. Right? They're all of the points on the y-axis, the x value is 0. So what we can say is if x equals 0, then we can use, here's my parametric equations right down here, the x equal and the y equal equation. What I can do is I can take this 0 and I can substitute it in for x to find out when that happens. Okay, that's what we're going to do. We're going to find when would x be 0. So we would say 0 equals 1 minus 1/2 t. So we get 1/2 t equals 1, or t equals 2. So this is the time when x is 0. So if we can figure out when x is 0, we can certainly figure out what y is at that same time, right? We can figure that out. So if I know that x is 0 when time is 2, I go into my y equation and I substitute a 2 in for time, and then I can see what the y value is then. So we do that. So y is going to be 2 squared minus 1, or 4 minus 1, or 3. And so therefore, we're satisfying what they asked, which was to show that A has coordinates 0, 3. So therefore A is 0, 3. Okay, so that's part A. Is that okay? That's the kind of questions we're going to be doing in this lesson, are using the equations, the parametric equations, to find various things they ask us to do. So on part B it says find the x coordinate of the point B. So again, that B is on the x-axis, so we know every point on the x-axis has a y coordinate of 0. Right? So for part B, this was part A. So for part B, we're going to be looking at, well, if y is 0, then if we can figure out when y is 0, then we can do the same kind of thing and find out what x is at that time. So if y equals 0, we would get 0 is 2t minus 1. So 1 equals 2 to the t. So this is just kind of a thinking problem. 2 to what power would give us 1? And that would be 0, right? 0. So t is 0. Now it's just a coincidence that these happen to be the same values. I want us to be sure we understand that. That's just a coincidence that y is 0 and t is 0. That doesn't always happen. But in this case, it does. So when y is 0, t is 0. So therefore, we can go back into the x equal equation and substitute our 0 in for t and find out. So 1 minus 1/2 times 0. So x is going to be 1. So to answer the question that they said, find the x coordinate of the point B. Well, the x coordinate is 1. Okay? Is that okay so far? All right, we have a few more problems that give us different versions of this. So let's go to the next slide. Alright, so the first example on the next slide, it says, it gives us some parametric equations again, x equals t minus 1 and y equals 4 minus t squared. Okay. The curve meets the x-axis at the points A and B. Let's think about that for a second. Curve meets the x-axis at the points A and B. We're talking about x-intercepts, aren't we? So if we meet the x-axis at A and B, then we're talking about x-intercepts, or zeros. And every point on the x-axis has a y value of 0, right? So we're going to be working that one this way. We need to know if, so when y is 0, which means it's on the x-axis, we need to find when that happens. Apparently it happens twice because we have 2 points on the x-axis. So let's plug in a 0 for y. So we get t squared is 4, or t is plus or minus 2. Okay, great. So we do have 2 times when that happens. So let's investigate each time. So the first, when time is -2, then I'm going to substitute that value in for x. So x equals t minus 1, so x equals -2 minus 1, or -3. So point A is -3, 0. So when t equals 2, I'm going to substitute a 2 in for t, so x equals 2 minus 1, or x equals 1. And so for point B, my coordinate point is 1, 0. I'm going to slow down here for a minute and make sure we're all okay. Am I going too fast? Is everybody okay? Alright, so that we were able to find the coordinates of both points A and B by using the same kind of technique, right? Just kind of think about what's going on. So let's look at number 2. So we have a curve is given parametrically by the equations x equals t squared and y equals 4t. The line x plus y plus 4 is 0 meets the curve at A. Find the coordinates of A. So this one's a little bit different. What we're being asked to do is we're given one curve in parametric form, and we're given the other curve in rectangular or Cartesian coordinate form. That's kind of weird. So we know that when two curves meet, that's the intersection. And if they were both in the same form, you know, if they were both in rectangular form, we could just do one of our systems, you know, set them equal to each other, or use substitution or elimination, some kind of procedure. But they're in different forms, so we need to approach it a little bit differently. Since they're in different forms, that's important, but basically they're still going to meet at the same x and y somewhere, right? If they intersect, they're going to have the same x and y somewhere. So what we're going to do in a case like this, when we have these mixed representations, one is in parametric form and one is in a rectangular form, is let's just substitute the parametric form into the rectangular form, right? Because that will give us the x and the y. I mean, we want to know when x and y is the same anyway, so let's force them to be the same. Let's substitute one of them into the other, and then we can solve and all will be just fine. Alright, so let's do that. So we're going to substitute the parametric into the rectangular equation. So where it says x right here, instead I'm going to put t squared. So t squared plus. Where it says y right here, instead I'm going to put a 4t. And then finish out the equation, plus 4 equals 0. So I need to know when they intersect. This equation right here will tell us when they intersect. And so we would factor or do whatever kind of technique we needed to do to find out what t is. In this case, we would factor. So they actually meet just one time when t is -2. That's when the two equations meet. So that's great. We know when they meet. But they actually want us to find the coordinates of where they meet. So since I know when, now I can go back into the parametric form and find where. So let's go back into the parametric form. So x is going to be -2 squared, or 4, and y is going to be 4 times negative 2, or negative 8. So point A is going to be at 4, negative 8. And those are the main types of examples that you'll see for this form of problem. Is that okay? So the last type of problem is the problem that, if you recall, I was telling you I moved it from the previous lesson because this problem takes a little while and that other lesson was a little bit too long. So this problem is different than these other problems that we're doing. But it has to do with parametrics. For time's sake, I went ahead and filled out the t-chart for you. That wouldn't have been given to you, this t-chart right here, but it takes, it takes time to fill this out, and just really to speed things up on the notes, I went ahead and gave you that. All right, we have a set of parametric equations and we have a restriction here. Our time is restricted between negative 3 and 4, and this table shows us the times between negative 3 and 4. Okay, I went ahead and did that for us. So let's see what this question is asking. It says for the given parametric equations, which is this little set right here, for the given parametric equations with this restriction, find the values of the parameter t that produce the graph in each of the 4 quadrants. So I'm trying to find the t values of when I'm in quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's what we're looking for. So our answers are actually going to be, like quadrant 1 is going to be some kind of t values, quadrant 2, t values, quadrant 3, and quadrant 4. So let's just get that set up. That's how our answers are going to look. They're going to have basically some inequalities over here with t's in them. So in order to figure that out, we need to graph it. And so the points over here, we're going to go with the points. Let's go ahead and put the scale on our paper. I really needed to go into halves, so I'm marking the whole ones 1 and 2, but we're going to need some half points in there as well for this one. So let's set up our scale so that we can graph this and figure out what's going on. Okay, so we have our scale set up. We have some they're basically in halves. So let's start the procedure. Let's start with the t of negative 3. When t is negative 3, my coordinate point is negative 1, negative 4. So negative 1, negative 4.5. Negative 1, negative 4.5. Puts us right down here. And I'm just going to log that with a t equals negative 3 so I can keep track of what's going on. Do you have to put those there? I mean, if you're not asked to, you don't have to, but it's just helpful to put that there. So that's kind of where we're starting. At a t of negative 2, I have an x value of 0 and a y value of 3.5. So we're going this way. And actually, I'm in the third quadrant, and when t equals negative 2, I am passing out of the third quadrant. So let's go to our third quadrant little notation down here. I started when t is negative 3. And I'm going to negative 2. Now let's look at the difference between the inequality signs. Why do you think I put a less than or equal to for the negative 3, but I didn't for the negative 2? Do we see why? Yeah, negative 3 is actually inside the third quadrant, right? What our job is to find the t values where we're in each of the quadrants. Well, at negative 3, we are actually inside the third quadrant, but at negative 2, we're on the quadrantal. We're passing out of the third quadrant, so I can't put an equal there at the negative 2. Okay, does that make sense? Why I have to do that? So now we have our quadrant 3 taken care of. Let's keep graphing and see where we go. So we just did negative 3 and negative 2, so let's do t of negative 1. It puts us at 1, negative 2.5. So here. Then at t equals 0 puts us at 2, negative 1.5. Okay, so it takes us out to here. 2, so that's a t equals 0, just to kind of keep track of what's going on. That's t equals 0. When t equals 1, it puts us at an x value of 1 and then a y value of negative 0.5. So it looks like we're turning. 1 negative 0.5 puts us right here. And then when a t value of, let's see, of 1, that's 1. A t value of 2, I'm at 0. X is 0 and y is 0.5. Okay, so I passed out of the fourth quadrant somewhere between the time of 1 and 2. Somewhere between that time, right? Because at time equals 1, I was in 1 negative 0.5, and time equals 2, I was 0.5. So since we don't know, we're going to have to calculate that. We need to know that. So when I pass through there, that would have been when the y value was 0, right? When y is 0, that's when we would have passed through there. And so what I have to do is go up here and put in a 0 for y, and t is going to be 1.5. Now, just strangely enough, it's exactly in the middle. It doesn't have to be. It could be anywhere in between 1 and 2. So it just, by coincidence, happened to work that way. So let's kind of fill out quadrant 4. So we entered into quadrant 4 at negative 2, a t of negative 2. And then we left quadrant 4 at a t of 1.5. And neither of those are included because both of those are on the quadrantal. Okay. So we're out of quadrant 4 now, and we're into quadrant 1. So quadrant 1 just kind of weirdly, we were on there just a short time, weren't we? We started in quadrant 1 at 1.5, at a time of 1.5. And we actually are already out, right? When t is 0, we are at 0.5. So, excuse me, when t is 2, we're at 0.5. So we're out of that first quadrant. All right, so let's finish this out. When t is 3, we're at negative 1, 1.5. So it puts us here. And then when t is 4, we're at negative 2, 2.5. And that's it. So we entered into the second quadrant at 2. And we are actually still in the quadrant at a t of 4. So I need to include the equal sign there as well. Okay. So sometimes students have a hard time with this kind of problem. Do we understand the logic of what's going on? We're trying to find the values of t for which we're inside a particular quadrant. Okay, and if they don't, so sometimes they're just really nicely on this chart, right? And sometimes they're not. If they're not on the chart, then we need to go find them. But we would need to find them, we're looking for when it crosses a quadrantal, right? For when either y is 0 or x is 0. We know how to do that. We know how to find when that would be, right? We would just go back to these equations and we'd either set x equal to 0 or y equal to 0 to find the time. Does that make sense? Okay. Alrighty.